Hey guys, welcome to our last example for 4.2, example 8. Let's say you're given a survey and you're trying to see what are the grades some of the kids have in their current math class, and here's what you get. So I'm going to do quite a few probabilities here using both sample space and addition and multiplication rules. I will use the method that I see as easiest first. So the first thing I want to do is just total each column and each row, so I can quickly see how many of each we have. So let's see, there's 5, 10, 14 A's. There's 6, 10 B's. And there are 4 C's. And then let's see, there are 7 ninth graders, 9 10th graders, 7 11th graders, and 5 12th graders. So the reason why I summed that up is because it helps me to just do the probabilities quicker when I'm doing the problem. And then hopefully these should sum up to be the same number, 28 total. 7 plus 9 plus 7 plus 5, 28. So this sum and this sum are both my total sample space of 28 students. Perfect. So what is the probability of being a ninth grader and having an A? Well, I can already see in my sample space there are only 3 ninth graders out of the entire 28 class that has an A. So that would be 3 out of 28, which you could plug into your calculator, which is about 0.11. or 11% chance. Well, probability of ninth and probability of A. Well, what if I wanted to do that with multiplication rule? So probability of being a ninth grader is 14 out of 28. So let me do this a different way in a different color. Part A. So being a ninth grader is let's see, 7 out of 28 multiplied by being a ninth grader, multiplied by getting an A, given that you're a ninth grader. So that would be multiplied by 3 out of 14, because there's only 3 out of 7, because there's only 3 ninth graders that have an A. So 7 out of 20A is being a ninth grader. Getting an A, given that you're a ninth grader, is 3 out of 7. Having an A, given that you're a ninth grader. And I still get 3 out of 28. So whether you do sample space or multiplication rule, you get the same answer. Okay, what's the probability of being a ninth grader? Well, we already did that in the last one. 7 out of 28, or 1/4, or 0.25%. What is the probability of getting a B given that you're a ninth grader? So probability of getting a B given that you're a ninth grader, it's going to be 4 out of 7. So 4 students have a B out of 7 ninth graders. So 4 divided by 7, it's 0.57. So now this one's the opposite. What's the probability of being a ninth grader given that you have a B? Well, there's a total 10 kids that had a B. 4 of them were ninth graders. So it's going to be 4 possible students who had a B out of, or 4 possible ninth graders out of 10 people who had a B, which is 2/5 or 0.40. So notice the difference. B, given that you're a ninth grader, 4 out of 7. ninth given that you're B. 4 out of 10. Okay. What is the probability of being a ninth grader or getting a C? Well, first, when we see or, we have to check, are they mutually exclusive? So is there anybody who's a ninth grader and a C? There are 0 students who are both a ninth grader and a C. So therefore, these events are mutually exclusive with this sample space. So the probability of a ninth grader is 7 out of 28 plus the probability of getting a C, 4 out of 28. That's 11 out of 28, does not reduce. 0.39. All right, let's see. Probability of being an 11th grader given that you have an A. So let's see, how many people have an A? 14 total people have an A. How many of them are 11th graders? 4. So therefore, that would be 4 11th graders out of a possible 14 kids who had an A. That reduces to be 2/7, which is 0.286 or 28.6%. All right, being a 12th grader or having an A. So first, when I see or, I have to check, are they mutually exclusive? Looking up at my chart, there are 2 students who are 12th graders and have an A. Therefore, they are not mutually exclusive. So I need to do probability of a 12th grader plus probability of an A minus probability of a 12th grader and an A. So probability of being a 12th grader, let's see. There are a total of 5 12th graders. So that's going to be 5 out of 28 plus probability of getting an A. Well, let's look up here. There are 14 students who had an A out of 28. 14 out of 28 minus the probability of being both a 12th grader and having an A. Well, there are 2 students here out of the 28. 2 out of 28. So I have 5 plus 14 minus 2, 17 out of 28. 17 divided by 28 is 0.607 or 60.7% chance. All right, what's the probability of having a 10th grader, being a 10th grader and having a C? I'm going to use sample space for this one because it's simple to see. How many 10th graders have a C? Only 1 out of the total 28 students. So the probability of being a 10th grader and getting a C is 1 out of 28 or 0.0357 or 3.57% chance. So this problem is a summary of ands and ors and givens, and we will be practicing probability all this week.